Hello and welcome. In this video, I'll provide a high-level overview on the best practice security recommendations that can be implemented on Alcatel-Lucent Enterprise networking products and solutions. My name is Abu Bakr Dongola and I am a Network Solutions Architect working for the Network Business Division at ALE. So here's the agenda. I will start with an introduction on why it is critical for businesses to implement the best practice security recommendations on their network infrastructure, not only to comply with security standards, but to prevent exploits from malicious actors. After that, I will go through security recommendations on the OmniSwitch platform, covering the management plane, control plane, and data plane. Next, I will do the same for the OmniAccess Stellar Wireless LAN solution and the OmniVista 2500 and Cirrus Network Management System platforms. Then I will cover general best practices when programmatically managing your network devices using technologies such as REST API. I will also cover security standards that ALE products are certified in. Next, I will go through the general additional security recommendations that should be followed to maintain a good cybersecurity hygiene. I will close with some key takeaways. So let's begin. So let us start with an introduction. Over the course of the last few years, almost every enterprise and government organization has changed the way its employees communicate, collaborate, and share information. While the rapid shift to support employees working from home was crucial to maintain business continuity during the pandemic, it came with a price. The network perimeter now extends well beyond the traditional office boundaries, significantly increasing the organization's attack surface. Implementing a comprehensive and multifaceted security strategy is indispensable to fortify your businesses against such threats. So as cyber threats continue to evolve and become more sophisticated, organizations must remain vigilant to safeguard sensitive information and maintain business continuity. Regularly reviewing certifications and ensuring compliance is paramount for data security, mitigating risks, and avoiding potential penalties. Implementing robust compliance measures not only protects your data, but also enhances your company's reputation and fosters trust among stakeholders. From an end-user perspective, security must be provided transparently to avoid adding complexity. Implementing a robust network security necessitates a comprehensive strategy employing multiple layers of defense. Several factors must be taken into consideration, but choosing a compliant and robust network infrastructure is key against protecting your network from malicious actors. With ALE products, security is not an option. So ALE products follow a secure by design approach. Below are examples of features which are enabled by default on OmniSwitch products out of the box. The first is DOS filtering. So by default, the switch filters denial of service attacks, which are security attacks aimed at devices that are available on a private network or the internet that aims to overwhelm or abuse resource usage of the device. In terms of security certifications, ALE products received the highest levels of certifications from major governmental agencies, including GITC, NATO, Common Criteria, EAL2, and NDCPP certification, and FIPS 140-2. Signed AES image provides verification of software integrity by providing the ability to determine if the AES software comes from a trusted source and to detect if it has been tampered with after signing. Using RSA 4096 and SHA-256, AES images are signed with a private key, allowing AES to verify the signature with a corresponding public key during reload and flash synchronization. The required public key and the intermediate CA bundle will automatically be set up on the switch for signature verification. Secure Boot is a feature that allows you to validate from system power on that the bootloader updates, FPGA updates, and AES images and packages are sourced from ALE as opposed to a third party. ALE products are cryptographically signed. Secure diversified code. So this employs multiple techniques to identify vulnerabilities such as software architecture reviews, source code analysis, vulnerability scanning tools, and techniques, as well as analysis of known vulnerabilities in third-party code. So ALE employs a set of technologies to ensure switch software integrity, including first, independent third-party verification and validation. So this includes source code analysis, white box and black box testing, searching for vulnerabilities in external interfaces. So the IVMV, it makes our switches more secure by providing source code level validation from a third party. Next is software diversification. So ALE software implements address space layout randomization. So every time you reboot the switch generates a unique memory layout. So this prevents exploitation of memory corruption vulnerabilities. Also, ALE provides a dedicated USA-based server for US government downloads. Also, ALE USA supply chain process enables designation of OmniSwitch models as TAA country of origin USA. So all of these features, which are embedded in ALE secured code, ensure that the highest security is provided at the network device level. ALE has continued to develop networking devices with security at the forefront. A comprehensive security framework must be established from the ground up and applied universally across all network access methods, whether wired or wireless. At ALE, we recommend an integrated security approach that focuses on every layer or level, beginning with the network level, then the device level, the user level, and finally to the monitoring and analytics. All of this should be based on a zero-trust architecture that uses both macro and micro segmentation, along with a strong network access control like Access Guardian, which provides the required authentication based on the principle of least privilege. This is provided based on user profiles. Finally, there should be continuous monitoring and enforcement of these policies. In short, by implementing a layered security approach, you are able to minimize the network security risks. Before we delve into the topics of the security best practices, so there's two concepts that I want to clarify, as this video will define the security recommendations based on them. So the first concept is the three functional planes concept, which are the management plane, the control plane, and data plane. The second concept is the CIA triad, which stands for confidentiality, integrity, and availability, which I will cover in the coming slides. So let's start first with the three planes. So what is the management plane? So the management plane is simply the functional layer, which is responsible for the administration, monitoring, and configuration of the device. So it's responsible for handling any traffic that is destined to the device. Examples of protocols or services that exist in this level are SSH, HTTPS, FTP, and SNMP. So what are the risks involved in if the management plane is compromised? So first, it poses a significant security risks, as any malicious user can take over control of the infrastructure, configuration, and operation, which can lead to interception and or theft of sensitive data or credentials and network downtime. That's why it's crucial to secure the management plane. The second plane is the control plane. So the control plane is the functional layer that controls or governs everything related to the forwarding of packets in your network. Examples of control plane protocols include the routing protocols like OSPF, BGP, and so on. So if the control plane is compromised, it can have serious negative consequences of your network, including loss of operational control and data breaches. The last plane is the data or forwarding plane. So it is responsible for forwarding the user traffic. So examples include QoS policies, traffic filtering, and any data in transit encryption. So a compromised data plane directly affects the confidentiality and integrity of user data. That's why it's critical to ensure that the data plane is secure. So these three planes are closely interconnected. The data plane is governed by the control plane, and the control plane is managed and configured by the management plane. The second concept I want to present is the CIA triad, which stands for confidentiality, integrity, and availability. So there's three pillars of information security, which are defined by NIST, which is the National Institute of Standards and Technology. So they allow you to publish a holistic approach to securing your information. So the first one is confidentiality. So this is to ensure that information is accessible only to authorized users. entities or processes. So this is especially important for PII, which is personal identifiable information, or any proprietary information or any sensitive data. So measures that can be used to ensure confidentiality is securing data in transit, including encryption, or by using NAC or network access control measures. A second pillar is integrity, which deals with ensuring that data was not altered or destroyed, and ensuring accuracy, consistency, and trustworthiness of your data. So examples of measures for protection include using hashing and digital signatures. The last pillar is availability, which is to ensure that your data, information, or systems are accessible and available when needed by authorized users. Protection measures include providing redundancies, continuous monitoring, and having regular backups. So we will start our security recommendations for the OmniSwitch platform. We have split the recommendations based on the type of functional plane, the management plane, control plane, and data plane. So we will mention the security risks, what are some of the recommendations to mitigate these risks, the suggested command, and which part of the CIA triad is affected by the risks. So please keep in mind that we are highlighting the primary pillar of the CIA triad, which would be affected, but in most cases, or a lot of cases, all three will be affected. So the first risk is the boot images and system variables. They can be easily manipulated by having physical or console access to the switch. Once you have physical access to the switch, you can easily modify the system variables from the U-boot. So this can cause many security-related issues, including management access compromise by resetting the admin password. As a recommendation, first, we need to restrict physical access. It's recommended that critical switches be housed in locked rooms with limited access. So second, we need to secure the console access to the switch, which can be done by restricting all users except the user admin from accessing the switch through the secure console session. Third, we need to secure the bootloader. So depending on the OmniSwitch platform, it may use the ONI or the U-boot bootloader. We can authenticate access to the bootloader with a complex password. Gaining unauthorized access to the management plane, primarily it affects the confidentiality and integrity pillars of the CI triad, but it can also affect or impact the availability in certain scenarios. So confidentiality can be impacted by exposure of sensitive configurations and credentials. Integrity can be impacted by unauthorized modifications to configurations and policies. Availability can also be impacted by potential service disruptions and management lockout. The second security risk is using weak SSH and SSL or TLS cryptographic algorithms. So these are vulnerable to brute force, collision, or cryptanalysis attacks. To mitigate this, you should enable the enforcement of strong SSH ciphers, HMAC configuration. HMAC stands for hash-based message authentication codes. This is used for integrity, and for high security using a high security level for SSL ciphers. So this enforces SSH to use strong ciphers and SSL to include strong ciphers such as AS256 with SHA-2 ciphers. Using weak SSH or SSL ciphers, it primarily affects the confidentiality pillar primarily of the CIA triad, but it can also impact integrity and availability indirectly. So confidentiality can be impacted since attackers can decrypt sensitive data, exposing passwords and configurations. Integrity can also be affected as data can be altered with man-in-the-middle attacks due to the weak hashing mechanisms. Availability can possibly be impacted as well, as some SSL or TLS vulnerabilities may cause service disruptions or denial of service. The third security risk is keeping unused IP services enabled. So this provides unnecessary exposure and increased attack vector. Our recommendation is to disable all IP services and selectively enable the required secure protocols. We will touch upon this in an upcoming slide where we will present the list of insecure protocols and what is their secure replacements. So not disabling unused IP services in your network devices, it primarily affects the confidentiality and availability pillars of the CIA triads, with potentially secondary impact on integrity as well. So confidentiality is affected with the exposure of sensitive system information, such as configurations, credentials, and network topology, leading to data breaches. Availability is impacted with the increased attack surface for DOS attacks. Integrity is not directly impacted, but network settings and security configurations may be compromised, leading to data integrity issues. The fourth security risk is not centralizing your access control, system logging, and accounting. This impacts your ability to respond to incidents timely and effectively in a consistent manner. We recommend to centralize access control, any system logging, and accounting through external servers to improve the consistency of access control, to allow network-wide controls of accounts, and to simplify and reduce administrative costs of account provisioning and deprovisioning, and provide accounting and audit trails for user and admin sessions. Also, if possible, if you can configure multiple servers for redundancy, and also to encrypt all the traffic between all the communication to the external servers. So having a lack of centralized access control, accounting, and system logging, it primarily affects the confidentiality and integrity pillars of the CIA triad. It also indirectly impacts the availability pillar as well. So confidentiality is impacted as unauthorized users may gain access to sensitive data, and distributed accounting and audit logs makes it difficult to track. Integrity is also impacted as well, since there's a risk of undetected modifications to system configurations and data. Since access control is not centralized and consistent, some users might have unauthorized access to network devices. Availability is also impacted since there will be a delayed incident response, which can lead to prolonged outages. The fifth security risk is using single-factor authentication for management access of your network devices. Usually this is a password, and passwords can be guessed or stolen. That's why we always recommend using multi-factor authentication. Multi-factor authentication will significantly increase your security level. So there's multiple use cases to implement multi-factor authentication on OmniSwitch, such as using Radius with an OTP or using Active Directory with OTP. So there's an application note which is available on Spacewalker's technical community website, which I will present it later at the end of this video. So not implementing MFA, it primarily affects the confidentiality pillar of the CIA triad, but it can also indirectly impact integrity and availability. Confidentiality is impacted as easier unauthorized access is provided to sensitive data. The sixth security risks which I want to cover is role-based access control. So not configuring role-based access control, it provides excessive or inappropriate access to users. So this can lead to potential breaches, data misuse, and operational disruptions. To mitigate this, of course, you need to set up role-based access control, a custom authorization per role or per the user type. In case you're using an external Radius server for access control, you can use vendor-specific attributes to configure the functional read-write privileges for the user. If you are using UPAM for authorization, you can use the bitmap calculator for the required access. UPAM is short for Unified Policy Authentication Manager, which is the unified access management platform for both OmniSwitch devices and Stellar APs. It is part of the OmniVista network management system, which has a built-in Radius server and can be used to implement multiple authentication methods, such as MAC authentication, .1x authentication, and captive portal authentication. In case you decide to use local authorization, although it's not recommended, you can set the required privileges when configuring the user using command domain names and command family names. So these are, I will show all of these and discuss it in the next slide. So not implementing role-based access control, it primarily affects the confidentiality and integrity pillars of the CIA triad, with potential secondary impacts on availability. Confidentiality is affected since users can access data they shouldn't see. Integrity is affected since users can modify or delete critical data. Availability can be indirectly affected by potential disruptions from misconfigurations or attacks. So this slide shows how role-based access control, or RBAC, it can be implemented with the three use cases we explained in the previous slide. So the vendor-specific attributes can be used when you are using an external Radius server for authorization, as shown on the table on the bottom left of the slide. If you notice that the type is hexadecimal, so this can be calculated using the bitmap calculator, which is available in OmniVista NMS. If you are using UPAM for authorization, you can use the bitmap calculator for the required access. This is shown on the top of the slide, so which is the capture of the OmniVista network management system platform. This is used for advanced privileges, which is part of the switch user account. Once you set the required privileges for the user, this will automatically calculate the bitmap, which is in hex, for that privilege. For local authorization, you can set the required access using command domain names, and command family names, as shown on the table on the bottom right of the slide. As mentioned in the third security risk earlier, it's recommended to disable all the IP services and selectively enable the required services. So when a switch initially boots up, all supported TCP, UDP well-known service ports are enabled or open. Although these ports provide access for essential switch management services such as Telnet, FTP, SNMP, they are also vulnerable to DOS attacks. So it is possible to scan open service ports and launch such attacks based on the well-known port information. The IP service command it allows you to disable or close the TCP, UDP well-known service ports selectively and enable them when necessary. So this command only operates on TCP, UDP ports that are open by default. It has no impact on ports that are opened by loading applications such as RIP or BGP. So insecure protocols, they are provided by US to support legacy systems. They are not recommended. Secure protocols are available which provide the same type of functionality. All services which are not used should be disabled to reduce exposure. You can use the commands shown on the text box to disable all IP services, and you can selectively enable the required secure services. For SNMP, it's recommended, of course, to use the most secure configuration, which is SNMP version 3 with the SHA and the AS. As you can see, Telnet is the insecure protocol, and a secure replacement for it is SSH. For FTP, a secure replacement is SFTP or SCP. TFTP, the secure replacement is also SCP or SFTP. SNMP version 1 and version 2 and version 2C, they are not recommended because they have some vulnerabilities. HTTP is an insecure protocol. It's always recommended to use HTTPS as well. And for NTP, it's unless it's not used, so it's recommended to disable it. And if it's enabled, it's recommended to use authentication. For Radius, it's recommended to disable it unless you use it in your configuration. So OmniSwitch, it supports multiple secure modes which can be enabled, which enforce certain additional security measures. So these modes were created due to the requirements of certain organizations or verticals to be compliant. However, it's not required for all use cases. So the first one is ASA, which is Authenticated Switch Access Enhanced Mode. So it's recommended to set this mode, which provides enhanced security restrictions by default, such as complex password policies and enforced default password modification. The second one is GITC mode. The third one is Common Criteria mode. And the fourth one is FIPS mode. So please refer to the Security Guidelines document and the Switch Management Guide for the functionalities of these modes. Now we will present the control plane top security recommendations based on the risks. So the first security risk is that routing protocols such as OSPF, ISIS, BGP, LDP, and many others, they are susceptible to route hijacking, corruption of the route table, and DOS or replay attacks. This can be mitigated by securing your routing protocols with authentication. So there's multiple methods to authenticate your routing protocols. If it's supported, it's recommended to configure keychain-based authentication with key rotation for the maximum security. Not securing your routing protocols with authentication, it primarily affects integrity within the CIA triad, but it can also indirectly affect availability and confidentiality. Without authentication, integrity is affected as malicious actors, they can manipulate routing updates. For example, they can inject false routes, or they can reroute traffic, or they can cause black holes. So attackers could also launch route hijacking or man-in-the-middle attacks, altering the intended path of the data. Availability can also be affected by attackers injecting bad routes or conduct route flapping, leading to network instability or denial of service conditions. Confidentiality is affected if traffic is rerouted through a malicious network. Sensitive data could be intercepted, leading to data exposure. The second security risk I want to talk about is the lack of protection of edge port misuse. So there's a lot of vulnerabilities which are associated with edge port security. To mitigate them, you should configure Learn Port Security, or LPS. I will discuss LPS further in the data plane recommendations. You should also configure .1x authentication whenever possible on the access ports, and you should filter or block BPDUs on edge ports. BPDUs stand for Bridge Protocol Data Units, which are used in the spanning tree protocol. So this will ensure that if a user connects an external or third-party switch on the network, that your network will be protected against spanning tree issues. A lack of protection against edge ports misuse, it primarily affects availability within the CIA triad. Edge ports are vulnerable to attacks like MAC flooding, spanning tree protocol manipulation, or rogue DHCP servers if not properly secure. Availability is also affected since attacks can exploit these vulnerabilities to disrupt network operations, leading to DOS conditions. Integrity can also be affected as attackers can manipulate network traffic using ARP spoofing or DHCP poisoning, affecting the integrity of transmitted data. Confidentiality is also indirectly affected. For example, if an attacker gains access to an edge port and he successfully performs packet sniffing, sensitive data might also be intercepted. The third security risk is that DOS attacks can be launched and they can exhaust the network device resources. So this can be mitigated by enabling DOS filtering. DOS filtering is enabled by default on OmniSwitch for most of the types of DOS attacks. Other mitigation techniques include disabling all unused ICMP messages, since they can be used to launch DOS attacks. We will discuss further on the types of ICMP codes to disable in an upcoming slide. Also, LDP security agent feature should be enabled to mitigate DOS attacks. The LDP security agent feature it can be achieved by allowing only one trusted LLDP remote agent on a network port. For example, when someone tries to take control over the network by connecting non-registered devices to a network interface port, the LLDP security mechanism is activated. So one of the or both of the following actions are performed according to the security configuration. So when a rogue device is detected, a violation is reported on the port. Also, the network interface port that is connected to the rogue device, it's blocked. So thus the rogue device is prevented from accessing the internal network. Another mitigation feature is to disable IP-directed broadcast. I will cover this in more detail in the data plane section. So DOS attacks, they primarily affect the availability aspect of the CIA triad. A DOS attack, it aims to overwhelm the system or service or the network with excessive traffic or resource demand. It renders the network device unavailable to legitimate users. So this directly violates the principle of availability. The fourth security risk is the man-in-the-middle attacks, which allow attackers to intercept or alter data between a sender and receiver. So there's many mitigation steps that can be taken for man-in-the-middle attacks, but primarily they include: first is to encrypt data in transit, which can be done using MACsec. MACsec, I will cover it in more details in the data plane security recommendations. Second, since ARP spoofing is a type of attack which is used for man-in-the-middle attacks, you should configure ARP poisoning feature and dynamic ARP inspection. The ARP poisoning feature detects the presence of an ARP poisoning host on the network. So this functionality uses a configured restricted IP address so that the switch does not get ARP response on sending an ARP request. If an ARP response is received, then an event is logged and the user is alerted using an SNMP trap. Dynamic ARP inspection, which is also called IP source filtering, it applies to DHCP snooping ports and restricts port traffic to only packets that contain the proper client source information in the packet. The DHCP snooping binding table is used to verify the client information for the port that is enabled for IP source filtering. Third mitigation is you can disable unused ICMP messages. I will discuss this more in the next slide. Other mitigation tools include blocking incoming gratuitous ARP packets to the switch, configuring learned port security on the edge port, switch supplicant feature, and the LLDP security agent feature. So what is the switch supplicant feature? It allows the switch to take up the role of a 802.1x client So when you enable this feature, the switch will, by default, it will be categorized as non-authenticated, and subsequently it will transition to a restricted state. So only the interface connected to the NAS switch will remain in the enabled state to undergo the authentication process. Once the switch gets authenticated based on the result, the switch will be moved out of the restricted state, and all admin-enabled interfaces will be made up. So man-in-the-middle attacks, they primarily affect the confidentiality and integrity aspects of the CIA triad. Confidentiality is affected as man-in-the-middle attacks. They involve an attacker intercepting and potentially eavesdropping on communication between two parties. So this compromises the confidentiality of the data being transmitted, as the attacker can read sensitive information. Integrity is affected since man-in-the-middle attack. The attacker may also alter the data or communication between the two parties, and they can inject malicious content or modify the data in transit. So this compromises directly the integrity of the data, as the recipient may receive tampered or falsified information. Availability could also be indirectly impacted if the attack disrupts communication or causes systems to fail because of the tampering. So ICMP introduces various security risks, such as man-in-the-middle attacks and DOS attacks. That's why it's recommended to disable unused messages and selectively allow others. The user should be aware of the risks of enabling ICMP messages. So ICMP messages, they are identified by type and code. So this number pair specifies an ICMP message. For example, ICMP type 0, type 4, code 0 specifies the source quench ICMP message. So as shown in the table, ICMP messages type 0 and 5, they should be disabled, while types 8, 9, 10, 13, 14, 17, and 18, they should be disabled unless they are required. Type 3 and 11 can be selectively allowed, but should be restricted. So the table, it highlights the purpose of the ICMP message and the security risk involved in each of the messages. So in OmniSwitch, you can disable an ICMP message by using the ICMP type command with the type and code. For example, to disable the source quench ICMP message type 4 code 0, enter the command ICMP type 4 code 0 disable. In addition to the ICMP type command, so there's many commonly used ICMP messages. They have separate CLI commands for convenience. For example, to disable a network unreachable message, you can put the command ICMP unreachable net unreachable disable. So the risks of data plane recommendations are similar to control plane recommendations. The first security risk is the lack of protection of edge port misuse. We have covered this in the control plane recommendations, and the same mitigation steps apply, such as using learn port security, .1x authentication, and to filter or block BPDUs on edge ports. So learn port security, it provides a mechanism for authorizing source learning of MAC addresses on Ethernet ports. Using learn port security to control source MAC address learning, it provides many benefits, including the ability to configure source learning time limit that applies to all LPS ports. You can also limit the number of MAC addresses allowed on LPS port. You can also set a dynamic or static configuration of a list of authorized source MAC addresses. You can also have three methods for handling unauthorized traffic. You can either administratively disable the port, you can stop all traffic on the port, but the port will remain up, or you can block traffic that violates the LPS criteria. As we mentioned before, the lack of protection against edge port misuse, it primarily affects the availability within the CIA triad. The second security risk is the man-in-the-middle attacks. So we've covered this in the control plane recommendations, and the same mitigation steps apply. You can use steps such as MACsec encryption. You can use ARP poisoning feature, dynamic ARP inspection. You can disable all unused ICMP messages. You can block incoming gratuitous ARP packets to the switch. You can configure learn port security on edge ports. You can use the switch supplicant feature and the LLDP security agent feature. So MACsec, it's or short for MAC security. It provides point-to-point security on Ethernet links between directly connected nodes. MACsec, it prevents DOS or man-in-the-middle attacks and other attacks such as playback attacks, intrusion attacks, wiretapping, masquerading, and so on. MACsec, it can be used to secure traffic on Ethernet links, LLDP frames, LACP frames, DHCP, ARP packets, and so on. MACsec enabled links that are secured by matching security keys. So data integrity checks are done by appending an 8-byte or a 16-byte header and a 16-byte tail to all Ethernet frames traversing the secured link. Also, optionally, traffic can be encrypted if it's enabled by the user configuration. As mentioned previously, man-in-the-middle attacks, they primarily affect the confidentiality and integrity aspects of the CIA triad. The third security risks is that DOS attacks can be launched and they can exhaust network device resources. We have covered this as well in the control plane recommendations, and the same mitigation steps apply, such as configuring DOS filtering, disabling unused ICMP messages, configuring LLDP security agent, and disabling IP-directed broadcast. So IP-directed broadcast is it's an IP datagram that has all zeros or all ones in the host portion of the destination IP address. So the packet is sent to the broadcast address of a subnet to which the sender is not directly attached. So directed broadcasts, they are used in DOS attacks. So in a DOS attack, a continuous stream of ping requests is sent from a falsified source address to a directed broadcast address, resulting in a large stream of replies, which can overload the host of the source address. By default, the switch drops directed broadcasts. And also mentioned before, DOS attacks, they primarily affect the availability aspect of the CIA triad. The next session is the wireless network security recommendations. So wireless net management plane security recommendations are similar to the switching one. The first security risk is not centralizing your access control, system logging, and accounting. We have also covered this point in the switching management plane security recommendations. This impacts your ability to respond to incidents timely and effectively in a consistent manner. So we recommend to centralize access control, syslog, and accounting through external servers to improve consistency of access control and to allow network-wide control of accounts, to simplify and reduce administrative costs of account provisioning and deprovisioning, and to provide accounting and audit trails for user and admin sessions. Also, if possible, to provide multiple servers for redundancy and to encrypt the communication if possible. As we mentioned previously, having a lack of centralized access control, accounting, and system logging, it primarily affects the confidentiality and integrity pillars of the CIA triad with indirect impacts on availability. The second security risk is using single-factor authentication for management access on your network. As we mentioned before, we recommend using multi-factor authentication, which significantly increases your security level. Not implementing MFA, it primarily affects the confidentiality pillar of the CIA triad, but it can also indirectly impact integrity and availability. The third security risk is not configuring role-based access control, which we have also touched upon in the security management plane security recommendations. To mitigate this, you need to set up role-based access control by setting a custom authorization by role or user type. Not implementing role-based access control, it primarily affects the confidentiality and integrity pillars of the CIA triad with potential security impacts on availability. The fourth security risk is to depend on the default self-signed certificate, which is pre-installed in your wireless devices. So this introduces the risk of man-in-the-middle attacks. To mitigate this, you can install custom client and server certificates on your access points, which can be used for management and between UPAM or external management servers and your access points. Using the default self-signed certificates on your access points, it primarily affects the confidentiality and integrity aspects of the CIA triad. So how is the confidentiality and integrity affected? Well, self-signed certificates are not issued by a trusted certificate authority, making them vulnerable to impersonation or man-in-the-middle attacks. So attackers can exploit this to intercept and decrypt sensitive data transmitted between users and the access points, compromising confidentiality. Also, without a trusted certificate, there is no guarantee that the access point is authentic. So attackers can spoof the access points and manipulate data in transit, compromising the integrity of the communication. While it's not directly affected, the use of self-signed certificate could lead to service disruptions if users or devices reject the untrusted certificates, preventing them from connecting to the network, so thereby affecting availability. The fifth security risk is the use of insecure management protocols such as HTTP and SNMP version 1 or version 2. So this increases the risk of data breaches, interception, and or altering management traffic, thereby allowing unauthorized access. The recommended solution is to replace or disable insecure protocols with secure alternatives, as we've shown before in the switching management plane recommendations. Any unused protocols should also be disabled, and communication should be encrypted whenever possible. Using insecure management protocols, it affects all three pillars of the CIA triad: the confidentiality, the integrity, and availability. Confidentiality is affected as some of these protocols they transmit over plain text, which can be intercepted, and integrity is affected as attackers can easily alter data in transit for these insecure protocols, compromising integrity. Availability is also affected since insecure protocols can be exploited to launch attacks to disrupt management access. In terms of control plane recommendations, the first security risk is the use of weak or outdated encryption methods, such as WEP or WPA2. So these introduce vulnerabilities such as replay attacks and crack attacks. They can also be easily intercepted, affecting integrity. So the recommendation is to use the latest security standard, which is WPA3 encryption, when configuring your SSIDs. It provides a more robust authentication and a stronger and improved encryption. In case you are using an open SSID, such as in coffee shops or airports, you should use the enhanced open feature to secure the communication. Using weak key encryption methods, it primarily affects the confidentiality and integrity aspects of the CIA triad, and weak encryption methods, they expose sensitive data to unauthorized access, directly compromising confidentiality. They also make it easier for attackers to tamper with data, so it also compromises the integrity. The second security risk is the lack of the WIPS feature, which is the Wireless Intrusion Protection System. So the WIPS system, it monitors the wireless radio spectrum for the presence of unsafe access points and clients, and can take countermeasures to mitigate the impact of these intrusions. So the lack of WIPS configuration, it introduces risks such as rogue access points, which can cause man-in-the-middle attacks and intercept traffic. Or an interfering access point, it can cause RF interference to legitimate access points. Therefore, it is critical to configure and regularly monitor your WIPS policies. Not using WIPS primarily affects confidentiality, integrity, and availability within the CIA triad, but most significantly, it impacts confidentiality. So attackers, they can set up a rogue access point to trick the users into connecting, and they can capture the sensitive data, compromising confidentiality. Rogue APs can also launch man-in-the-middle attacks to alter or inject data, compromising integrity. Availability is also affected by interfering access points, causing RF interference and jamming the signal to legitimate clients. The next section is the Network Management System Security Recommendations. The first security risk is not configuring role-based access control, which we have also covered in the switching and wireless management security recommendations. To mitigate this, you need to set up role-based access control by setting a custom authorization by role or user type. Not implementing role-based access control, it primarily affects the confidentiality and integrity pillars of the CI triad, with potential secondary impacts on availability. The second security risk is using single-factor authentication for management access of your networks. As we've mentioned before, we recommend to use multi-factor authentication, which will significantly increase the security level. Not implementing MFA primarily affects the confidentiality pillar of the CI triad, but it can also indirectly impact integrity and availability. Another security risk is onboarding your network devices insecurely to your network management system, especially if this is a cloud-based network management system. Any attacker can spoof the serial number or MAC address of your network devices and onboard them to their own network management system. It's recommended to use the network ID feature with strict mode enabled. So this will secure the onboarding process by matching the network ID from the devices with the network ID in OmniVista. This helps to prevent your devices from being onboarded or managed by someone else's OmniVista. If the DHCP server is configured with your network ID, devices will get the network ID from the DHCP server and specify it whenever they call home. You must configure your DHCP server option 43, sub-option 133 with your network ID. By default, the value is displayed in string format. Select hex format to display the network ID in hex format if your DHCP server needs the value to be entered in hex format. When strict mode is enabled, devices that do not send the network ID when they call home will not be allowed to be associated with this OmniVista Series system. The system does not allow devices without a network ID to be associated with OmniVista Series. So another security aspect that should be considered is API security. So this is often disregarded by many, but API security is crucial for safeguarding data, services, and systems that are exposed through APIs. So here are some of the best practices for securing APIs. First, you should enforce HTTPS or TLS encryption for API communication by disabling the WebView access in your OmniSwitch. Yeah, you should also disable the WebView services on your OmniSwitch devices and the Stellar APs to disable API exposure in case you are using OmniVista 2500 or Cirrus to manage your network devices. You will still be able to make REST API calls to your OmniVista platform. Also, you should rely on token-based authentication, such as OAuth or JWT. So OmniVista Series 4.x and 2500, it uses the OAuth 2.0 protocol to authorize and authenticate calls. It provides secure access to protect your resources, thereby reducing the hassle of asking for a username and password every time a user logs in. After successful login, you will be provided with access token, which can be used to authorize the rest of the API. On the Vista 10 platform, it uses an authentication mechanism based on JSON Web Token, which is the JWT, which is an open standard that defines a self-compact and self-contained way for securely transmitting information between parties as a JSON object. The next recommendation is to create a dedicated user for API access. So this will allow you to audit any user activities from that specific user. Also, you should apply the principle of least privilege, so ensure that users or services accessing your APIs only have the minimum access rights necessary to perform their task. You should also use strong and complex passwords, especially for API access. You should also avoid exposing APIs to the outside world, such as the internet. You should also store your authentication credentials securely and don't store them in code. You can use a third-party application to store and manage your tokens, passwords, certificates, and API keys. So let's go over a few additional security recommendations and resources. Unfortunately, even mature secure codes such as OpenSSH and OpenSSL used in AOS have security updates. It's important to apply these updates to your network as soon as they are available. Since vulnerabilities are publicly disclosed, they are also known by malicious actors who will exploit these vulnerabilities, which is why it is critical to apply these patches as soon as they are available. Physical access to switches, access points, and wiring closets. They allow malicious actor to power cycle a switch, to remove or replace critical components, or to alter or change the cable wiring. Once you have physical access to the switch, you can easily modify the system variables from the bootloader. So this can cause many security-related issues, including management access compromise by resetting the admin password. It is recommended that critical switches are housed in locked rooms with limited access. Without information security awareness training, employees may accidentally leave network elements vulnerable to misuse. As corporate security policies evolve and threat actors innovate new ways to maliciously harm victims, organizations have to adapt to these changes and educate employees on maintaining a good cybersecurity hygiene. ALE offers training classes to enhance the network personnel skills. In addition, ALE provides a number of user manuals, including the OmniSwitch user guides for detailed CLI syntax and other security configuration options. Following is a list of user guides which are available. The network administrator will reference a combination of those user guides to configure the OmniSwitch features through CLI or Stellar Wireless LAN via OmniVista. Other user guides for hardware, fiber optic transceivers, and data center specific features are also available to support these functions. We also have a document available which provides suggestions and best practices for adding and maintaining security of your OmniSwitch, Stellar Wireless LAN, and OmniVista NMS network with secure configuration. It is available on our Spacewalkers website, which we also invite you to visit. So Spacewalkers is a technical network community website and a dedicated space for users, customers, and partners to connect and share about ALE network products and solutions. At the heart of Spacewalkers sits the forum where members can ask and answer questions. So there's a vast array of technical resources such as datasheets, Visio stencils and diagrams, demo videos, solution guides, and much more. It's available on the platform. It contains ALE latest network news and blog posts written by technical subject matter experts. Access to Spacewalkers is free, but you need to log in and to access the resources. At ALE, it is our goal to ensure that our products are developed with all appropriate security principles as basis. We follow a comprehensive security program that combines secure software development, best practices, processes, and tools. We also follow rigorous product security requirements. Also, we do periodic validation and quality of security testing before releases. So despite all of these security principles and related actions, vulnerabilities can be discovered in the software components of our products, which when exploited can have an impact on the security level of these products once deployed in customer networks. ALE has a dedicated Product Security Incident Response Team, or PSIRT for short, that manages requests, investigations, and reporting vulnerabilities or technical issues that are impacting ALE products. We report vulnerabilities to our business partners and customers with a detailed description of criticality and publish public vulnerability advisories with available upgrades and fixes and relevant software version. So ALE PSIRT works with third-party coordination centers such as CERT, IST, NVD, and US CERT to manage vulnerability notices. The reports are referred to with a common CVE, or Common Vulnerabilities and Exposures number. So we strongly encourage individuals or organizations that are experiencing any technical security issues with an ALE product or solution to contact ALE PSIRT. The details are listed in the webpage highlighted at the bottom of the slide. So in addition, ALE continuously aligns and collaborates with EU and other national bodies to ensure alignment and compliance with regulations such as NIS2 or CRA. Now let's close with some key takeaways. We have covered the best practice recommendations to secure your ALE products, but due to the diversity of information systems, it is important for the network administrator to have a comprehensive multi-layer cybersecurity strategy to protect critical business assets. In addition, software should be patched regularly, physical access to the network devices should be secure, and information security awareness training should be provided to employees. It is recommended as well to be regularly updated with new threats by subscribing to relevant security advisories, such as ALE Security Advisory and US CERT. Thank you for watching.